in there, and
No,
Libertarians like no government.
I thought Democrats wanted strong government and Republicans want less government.
Yeah,
Okay. Lesson 24.
Libertarians just says no government.
Let's talk about some derivatives. Again. So, we first learned definition of derivative a week or so ago. And when we used definition of derivative, it looked very similar. Well, it was this right here. Sorry, I was pointing at the wrong one. Where it was the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, that's the one we've been using officially. Now, what we're going to use an alternative option, and it's just changing up the letter, to do the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Which the only difference is basically all your delta x's are replaced with h's. Okay? In the homework, you've been seeing limits with f of x plus h, right? We were seeing those before we ever did definition of derivative. So this is just an official another way to see it. I know we're probably going to prefer h just because it's easier to write than delta x. But so example 1 is just using this new notation to do a derivative. So use the h notation for the definition of derivative to find g prime of x, given that g of x is the square root of x. Got it?
Yeah.
Okay, let's go then, right? So, first of all, we're being asked to do g prime of x. So that is common derivative notation. And if we're using our new one, it is the limit as h approaches 0 of, f of x plus h. Every place I see in x, I'm going to replace it with h. So my function is square root of x. So if I take that x and replace it with x plus h, this is going to be square root of x plus h. So that's my f of x plus h minus f of x. That's just the function they gave you, which is minus square root of x all over h. That's good. You've got it stuck in your head, though. Now, as we look at this, what happens if I go ahead and plug in 0 for h right now?
We get 0.
You'd get 0 over 0, which is what we call an indeterminate form. We don't know what the limit is when we get 0 over 0. We have to work with it. So, square root of x plus h minus square root of x. We need to deal with that. And so we're going to multiply, instead of multiplying by the conjugate of the denominator, we're going to multiply by the conjugate of the numerator. So what's the conjugate of square root of x plus h minus square root of x? Right, just change that minus to a plus. So we're going to multiply square root of x plus h plus square root of x. Now, what I do to the numerator of a fraction, we're going to do to the denominator. So square root of x plus h plus square root of x. Okay, next line. The limit as h approaches 0. What do we have to do on top? This is FOILing. So, as we FOIL, first, square root of x plus h times square root of x plus h. X plus h. What happens when you multiply conjugates to the outside and inside terms? They cancel, right? So you'd have a plus square root of x times square root of x plus h, and a minus square root of x times square root of x plus h. So my midterms cancel. What's last? Yeah, minus square root of x times positive square root of x. Well, square root of x times square root of x is x. A minus times a positive is a minus. Over my denominator is h times square root of x plus h plus square root of x. I mean, you can distribute that h in front of each radical, but it's not going to make life any neater there. Okay, continuing. Let's clean it up. Limit as h approaches 0 of, what happened on top? Your x's end up canceling. So officially we have an h over h radical x plus h plus radical x. Now what happens? Now I have an h on top and my denominator has a factor of h, so h's cancel. What's going to remain on top? That 1. I mean, officially there's a 1 on bottom too, but. So, equals the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. And now what? Okay, take the limit, so we're going to put 0 in for h. Now I'm no longer going to write the word limit because we're plugging it in. So it's going to be 1 over square root of x plus h becomes square root of x plus 0, which is square root of x plus another square root of x. What is square root of x plus square root of x? 2 square root of x. Questions? Now, okay, so a couple of things. First of all, yes, you could rationalize. I'm not going to because I'm going to do something different. But if you rationalize, you multiply by square root of x. So it becomes square root of x over 2x. I want to ask, what is this if we change and write it with exponents? If I say this is 1 over 2x to what power is the square root of x? 1/2, right? The way I have it written right now, because I left it in the denominator. So, just try to get you thinking ahead about something. 1 over 2x to the 1/2. If you take that x to the 1/2 out of there, out of the denominator, what does this become? When you take x to the 1/2 out of the denominator, it becomes x to the negative 1/2. And that would take it up to the numerator or just make it a whole part. The 2, though, however, has to stay in the denominator. So my point that I'm trying to get to is that I could write this as 1/2 x to the negative 1/2 as well. Yes, I know, I just wrote it with a negative exponent, but again, I'm trying to prove something later on. Okay. Questions on that definition of derivative? Gave us another opportunity to practice, which is good. So, excuse me. Okay. We are going to learn our first derivative rule today. I mean, we've learned definition of derivative, but we're going to learn how to do derivative when there's an exponent. Okay, there's lots of special case derivatives that we will work to learn over the course of our year together. But we are learning today, how do you do the derivative when it's x to some power and that power is a number? Okay, so basically what this is saying right here, d dx, so the derivative of x to some power is going to be n times x to the power n minus 1. Now, the short of it is, you take that power, whatever it is, and you move it out front and multiply that power out front. And then what's left in the power is you subtract 1 off of the original power. Okay? I promise it's easy, and you'll get it going very quickly. Okay? Let's try it with numbers, and I think it'll make work better for you. So, example A. F of x is x cubed. Now, we could do definition of derivative if you want. Kind of overkill. We can also just use our rule. So, if f of x is x cubed, f prime of x. So, my in value is 3. So, what happens? Are you guys okay with saying 3x to the 3 minus 1? Or we basically put the power out front, 3, and then we subtracted 1 within the power. What does this simplify to be? 3x squared. Again, you move the power out front and multiply, and you subtract 1 within the power. That's the short of it. Now, what about B? How does this rule apply to example B? Yeah. Everything we work with today has to be x to some power. So, if this is 1 over x to the first, what is this when I take this out of the fraction? X to the negative 1. So, can you do the derivative of x to the negative 1? So if my original function is x to the negative 1, what happens with my derivative? Becomes what?
Negative 1x. Negative 1.
So if we write it out, what I'm going to call longhand, because after today you won't see me write it like this. I'll just put the answer essentially. Okay? Negative 1 I moved out front. I subtracted 1 within the power. What does this become? Okay. He said negative 1x to the negative second. Are you guys okay if I just say negative x to the negative second? Now, if you get in this situation, you're not allowed to leave a negative exponent. How can I write this? Negative 1 over x squared, or the negative of 1 over x squared. I can't tell. Are we okay or not okay?
This is line.
Okay. Well, if you're okay, let's try C. Now, again, in order to use our derivative power, or our derivative rule, this has to be a power. The fifth root of x squared. X to the 2/5, does that sound familiar to you? Because your power goes on top, whatever the root is, or the index of the radical goes in the denominator, so x to the 2/5. So, if I'm going to do h prime of x, this is, move the 2/5 out front, 2/5 x to the, in my exponent, it's going to be 2/5 minus 1. Okay, not fun, but it's still going to be better than using definition of derivative. That's what you have to look at. So clean this up. 2/5 x to the, what is 2/5 take away 1? Okay, so 2/5 minus 5/5 makes it negative 3/5. Now, depending on the situation, you might be able to leave it like that. What about if you're not allowed to leave a negative exponent? What goes to the denominator? Okay, so I'll do that in a moment. But it's x to the 3/5 goes to the denominator right now, yes? What about the fraction 2/5? Yeah. It's 2/5, so that's the fraction. X to the 3/5 goes with it. One way, you might be able to leave it as like this. You might be able to leave it like this. Or, Daryl mentioned putting it back in the root form. If we put it back in the root form, this is 2 over 5 times the fifth root of x to the third. That's the one I have boxed. Honestly, it just kind of depends on the situation.
You changed it from 3s to 2s. From 2s to 3s on accident.
Say what?
Oh yeah, never mind. I was thinking too much.
Are we okay?
Yeah.
I started thinking, I was like, crud, what did I change?
Yeah, no.
Should we rationalize it?
I totally forgot about the minus 1.
We're not going to. They don't do a lot of rationalizing, so. Are we okay? And we could rationalize, but we're going to avoid it. I have one more example I want to throw at you. You can call it part D if you want. And that is g of x is the square root of x. That's the one we're going to end on. So in order to find g prime of x, what do you have to think about here? G of x, or the square root of x, is x to the 1/2. So, what's g prime of x become then? 1/2 out front, x to the negative 1/2. I wrote mine as 1/2 minus 1. But 1/2 x to the negative 1/2. Why did I do this problem?
That's the same answer we got in G1
Is this what we did definition for derivative up above? When we did all the big long work?
You're so limiting.
I wanted to make sure you guys really understand what we are shortcutting here.
Yeah, that's a major shortcut though.
I learned this the first day.
Okay, so notice
Why do we need to
I just did g of x was the square root of x. That's what was given up above. I found the derivative to be 1/2 x to negative 1/2. Notice, what did we get up here? 1/2 x to negative 1/2. Now, do you get to forget definition of a derivative at this point?
Yes.
No. I will tell you, one of the big places you'll see it is they might give you something that you have to recognize as definition of a derivative, but then you can shortcut and take the derivative by hand. Okay? Or maybe, it's more going to be a matter of being able to recognize, oh, that's in the form definition of derivative. Okay? So, how do you feel? Betrayed that I didn't teach that to you. But the thing is, had I taught this to you, you would have never put any effort into figuring out definition of derivative.
That's kind of the idea.
But I need you to have put some effort into definition of derivative. I need you to have an idea of how that works. So, just be this. No, you don't want definition of derivative. You just want derivatives.
Yes,
Yes,
that's our
Yeah, what's that text over?
X